In this segment, we are going to discuss a problem on torsion. So, what this problem tells us is this. There are two gears, G and D. Now, the mean radius of the gear G is 75 mm and mean radius of gear D is 200 mm. Okay, and uh, and then at C and H they are mounted on frictionless bearing on the brackets, and at E and F they are subjected to the respective torques. That means at TF a torque is being applied and it gets transmitted through the gear G to D, and through that it transfers to E as a torque at E. Now, if the allowable shearing stresses for both the shafts, say tau allowable is equal to say 75 megapascal, sorry, megapascal, then we need to find out, the question asks us to find out the diameters required for the shaft FGH and CDE. Now, these problems, and then a point to be noted here is, because see, the only the allowable shear stress is mentioned, so we need to design only with respect to the maximum stress developed. In some cases what happens is it will be told that even the deflection, the twist, must not exceed something, so that is designed for deflection and or stiffness, you can say, and this is designed for stress or strength. Okay, so this question is asking us just to find out the shaft diameter based on the maximum stress that gets developed. Now, so in this case we will say that say that the torque that we are applying is say at F is say 150 Newton meter, but then what will be the torque that gets transferred to DE, because we know that it gets amplified because the forces at this point, okay, so they are equal and opposite, but because the for example, okay, I'll draw it here. So if there is a gear like this and there is another gear like this, okay, now the force that comes here and here, so they are same because they are the action and reaction forces, but then this radius and say R1 and R2, now so they make the torque different, because R1 F is the torque that acts here, is equal to T1, and R2F is the torque that acts there. Okay, so that's how and then because so here we should not equate the torques but the forces. That means here we will say torque, in this case we will say torque at G divide by torque on D, the gears, is equal to or best thing is, okay, from here if I write, so implies F is T1 over R1 implies F is equal to T2 over R2. So in this form only I want to write, so that it will be clear. T2 over R2. I want to write in this form. So Tg over Rg is equal to T D over RD, right? So, so this will implies that torque at D, which will be equal to RD over RG times TG. Okay, and so that implies torque at E basically, which is same as torque at D, which will be equal to RD over RG times TG is again equal to TF. That means the torque at E will be so RD is 200 by 75, so it's now it will become 400 Newton meter. Okay, that means the shaft CFG, let me write it there. So if I write for the shaft CDE, okay, CDE. Now suppose I design that tau max or allowable. I'll write allowable. Okay, so it should be equal to the tau max which gets generated, and that will become equal to the torque at say E times C, which we actually we want to calculate, divide by J. Okay, so that will be equal to 2 TE divided by pi C cubed. Okay, because J will be pi sixth power 4 over 2, and from here we can calculate that. From here we can calculate that C, that is the radius of the shaft CDE, will be equal to 15.03 mm, or the diameter of CDE shaft is equal to 30.1 millimeter. And exactly in the same way, if we want to calculate for the shaft FGH, right? Okay, FGH. If I want to write, then again the tau allowable is equal to tau max in that shaft, which will be equal to torque at F times C in that shaft divided by J is equal to 2 TF over pi C cubed. Okay, and implies here C will be equal to, so this is of FGH, C of FGH, so that will come out to be 10.84 mm, implies D of FGH shaft will be 21.7 mm. So this is how you should calculate the maximum shaft dia which is required from the strength perspective. If it is also required to find out from the deflection, you have to see the deflection for which whatever diameter it comes out, and the higher one has to be chosen because you have to be safe. Okay, suppose from deflection your requirement comes for D FGH comes out to be say a 25 mm dia, so then you have to go for 25 mm dia, otherwise it will fail in deflection rather than failing in yeah It'll fail in stress before it fails in uh, what deflection. Yeah. So that is a problem on torsion. In the next segment we will see another problem on torsion.